Welcome to this presentation on information modeling, using Enterprise Architect and the Sparks modeling platform. You will learn about some of the tools and facilities available to data modelers and informaticians to create and manage rigorous information models, including conceptual, logical, and physical data models. You develop and review the models collaboratively, and you can share them with customers and a range of other disciplines from managers, business and process analysts, testers, implementation teams, and more. In this presentation, we will cover the following topics: manage entity relationship, conceptual, logical, and physical data models. Connect to live databases with the Database Builder. Transform models and generate database definition language. Link to other business and technical models. Communicate, collaborate, and integrate with Model Exchange. Create conceptual, logical, and physical data models. In this topic, you will see how to manage entity relationship, conceptual, logical, and physical data models. By the end of the topic, you will have seen benefits, including visualize and trace conceptual, logical, and physical data models. Change diagram notation standards. Get a jump start with data modeling patterns. Use diagram tools like pan and zoom, filters, layers, and legends. And more. Model entities and their relationships using entity relationship diagrams, which is the preferred representation for some business professionals and informaticians. You use them to model things of interest in a specific knowledge domain. The tool has rich support for ER diagrams, including generating them to physical data models. You can change diagram styles, including adding colors and gradients and changing fonts. You can also use a range of productivity tools to change the diagram layout, define filters and layers, and apply dynamic legends. Model entities conceptually, leaving the details to be resolved in logical and physical models. Use the information engineering standard or associations to show element cardinalities or multiplicities. Change the diagram appearance to whiteboard, custom, or hand-drawn mode, creating a feeling that the diagram is still in flux, inviting stakeholder input. You can color elements and connectors to indicate semantics, groupings, or use dynamic legends to color the diagram objects and connectors based on system or user-defined properties. Create or view logical data models using several connector standards, including the information engineering and unified modeling language notations. Communicate with business and technical stakeholders using the diagrams to gain feedback on their information requirements. Generate physical data models in a range of database management systems directly from these diagrams using the powerful and configurable transformation facility. Import or design physical data models and create expressive diagrams to visualize various database objects, including tables, views, primary and foreign keys, functions, stored procedures, and more. Connect to a live database and import the physical data model from the most commonly used relational database management systems. Use diagram tools such as layout, filters, legends, and hide compartments and detail to make the diagram more appealing to a range of stakeholders, including business analysts and architects, informaticians, business analysts, and developers. Change the diagram connector notation to comply with your team's data modeling standards. Use the diagram properties to change the connector notation to information engineering, unified modeling language, or integration definition for information modeling notation. You can also change the connector styles, including line color and thickness. Get off to a flying start by automatically injecting elements and diagrams or complete data modeling package structures into your repository using the Model Wizard patterns. Browse the extensive pattern library, which contains patterns for creating data models for different database platforms. Peruse the documentation accompanying each pattern to understand the benefit it will bring, and how best to work with it. Switch perspectives and gain access to hundreds of other helpful analysis, strategic, requirements, information, user experience, and model publishing patterns. Trace elements in conceptual, logical, and physical models to show how entities at different levels of abstraction relate to each other. You can choose to display an element's location in the namespace hierarchy as a prefix to its name in a diagram. The traceability window provides an alternate view of element connectivity and can reveal connections that a modeler has chosen not to make visible in a diagram. Get easy access to data modeling tool facilities from well-organized ribbons and panels. Launch the Productive Database Builder tool, import models of live databases, or forward engineer a model to database definition language (DDL) and create or modify generation templates. Access other tool features, including diagram layout options, filters and layers, pan and zoom, baselines, collaboration tools, and more. Create and view database objects, including tables, views, and functions in a spreadsheet-like view, with properties such as status and priority listed in columns. If you are accustomed to working with spreadsheets, this will be a welcomed view that allows you to sort and rearrange properties and edit both system and user-defined properties from drop-down lists. Enjoy the productivity of working in this familiar data paradigm, and switch to other views such as list, diagram, and Gantt views when needed. Use the handy pan and zoom window during analysis or workshops to focus on a region of interest in an open diagram. You can quickly move around the diagram at a readable resolution using the focus rectangle, which sets a viewport. Zoom in and out using the magnifying tool, the slider, or the mouse wheel, and explore any large diagram following the flow from the top left corner to the bottom right corner of the diagram. Connect to live databases with the Database Builder. In this topic, you will see how to use the purpose-built data modeling tool and synchronize models and live databases using the Database Builder. By the end of the topic, you will have seen benefits, including focus on data models with the Database Builder tool. Make live connections to any number of databases. Compare and synchronize models and databases. Create and run SQL queries and DDL execution queues. And more. Focus on data modeling and management with the Specialized Database Builder. This window provides productivity features that put database tools at your fingertips. Make connections to existing databases, create and edit database objects, including tables, views, procedures, functions, and more. You can import models from existing databases, link them to other modeling elements, compare the model and the database, and synchronize them in either direction. Generate DDL statements in a queue and execute them on the active database. Connect to implemented databases and get access to the Enterprise Architect's rich support for data modeling with a purpose-built tool. Make connections to multiple databases, including development, test, and production. Visualize database objects, such as tables, views, functions, stored procedures, sequences, and more. Configure columns, data types, primary unique and foreign keys, and view the objects in automatically created and laid out diagrams. Compare the current data model with a live database and optionally synchronize any differences in either direction using differential DDL. Use the SQL Scratchpad to run ad hoc SQL queries against a live database. Compare your physical data model and the live database. The Database Compare facility provides a mechanism for comparing the current data model with a live database and optionally synchronizing any differences in either direction. View the affected tables, columns, and other database objects in the Details panel. Differences pushed into a live database are performed using alter DDL statements, while changes imported from the live database can be directly pulled into the model. Visualize data from multiple tables with views. A modeler defines a view in a query from several tables defined in the schema and specifies the columns to be displayed in the result set. You can visualize the views in a conceptual, logical, or physical data model and connect them to the dependent entities or tables. You can add notes to annotate the purpose or significance of the view from a business or technology perspective. Create, save, load, and execute SQL queries against any connected database using the SQL Scratchpad. Utilize the IntelliSense editor to reduce errors and produce well-formed queries. View the results in the lower panel of the editor and copy them to a CSV file for import into a spreadsheet. The queries are conveniently stored in the database tree structure, and a modeler can add notes and discussions, and other properties to the queries. Create a physical model in a diagram or directly in the database builder and switch between these alternate views of the same underlying model. Changes made in either view will immediately be visible in all other visualizations, including list, Gantt, and specification views. You can choose to hide information in a diagram to make it more appealing or relevant to a particular audience. Selectively display columns, keys, and indexes by suppressing features for a logical or physical table in a diagram. You can use this to create tailored and curated views of your data models for particular audiences. Suppress identity columns, indexes, or other features not relevant to the selected audience. You can also suppress data types or display notes to completely tailor individual elements in a diagram. Generate a sequenced execution queue in the database builder, reflecting changes made to the model. View the task, action, and associated DDL script in a single window. You can execute each isolated statement, or by selecting Execute All, let the system run each statement in its execution order. The system displays the results in the panel below, indicating the success or otherwise of the execution. View the execution results indicating which actions have been successfully executed on the active live database. Each task is listed against the applicable database object with a description of what action was performed. You can then return to the data model diagrams or the objects in the database builder to view how they have been altered. Manage database definition language using the fully featured built-in source code editor inside Enterprise Architect. Develop your generated DDL scripts or SQL queries in the same tool you use to model your databases, business and technical requirements, process models, designs, and tests, allowing you to see the scripts in the problem and solution context. Use features like line numbers, syntax highlighting, search, IntelliSense, and more, to create production-ready SQL scripts. Take snapshots of parts of your repository at important milestones, and then run the differencing tool at any point in time to identify what has changed since the baseline. The differences are finely grained and identify name, property, and diagram layout changes. Set options to exclude unimportant changes and show elements that exist in the baseline but not the model, and vice versa. Create any number of baselines for any package in the repository hierarchy and manage them using the Baselines window. Transform data models and generate database definition language. In this topic, you will see how to utilize tools to convert models from conceptual and logical to physical models and then generate DDL. By the end of the topic, you will have seen benefits, including reverse engineer databases to physical data models, transform conceptual and logical models, specify transformation and generation with templates, configure data types and mapping options, and more. Transform from a logical to a physical model in preparation for generating database definition language. The transformation is driven by a series of connected templates that can be used in their base form or modified to suit an organization's modeling or coding standards. A data modeler can specify any supported database system as the target, and the system will convert the data types accordingly. Generate database definition language from a physical data model using the transformation tool. Use system-defined templates or tailor the templates to specify the format and output required to suit your organization's data modeling and coding standards. The DDL can be generated to a file and executed outside the tool, or to a dependency-ordered execution queue that can be run inside the tool. Specify the DDL transformation output by using or modifying the system templates. The tool provides a series of connected templates, and using the flexible template language, you can precisely specify the database definition language output. You can use system-provided macros to convert names and database types. You can also debug the generated output by viewing intermediate language text generated during an executing transformation. Reverse engineer a DBMS schema and its objects into a model, and create well laid out and formatted diagrams, using several different standards, including UML, information engineering, and IDEF1X. Enterprise Architect achieves this by interrogating the DBMS's information schema and importing the definition into UML objects. As modifications are made to the live database, the changes can be synchronized into the model. Many database objects are supported, including tables, views, procedures, functions, and sequences. Transform from a physical to a logical data model by using a custom template that removes the indexes and keys from the operations compartment of the class representing the table. The transformation is driven by templates that can be configured to meet your organization's modeling standards. Once the logical model has been generated, you can connect entities in the logical model to other system models such as activities in business process diagrams, requirements, or applications to show where data is created or consumed. Set database definition language generation options to specify what database objects, constraints, and indexes you generate from the model. Flexibility and configuration are essential when generating database definition language (DDL) from a physical data model. Use the DDL generation options window to set a range of options the system uses to inform the generation process. You can selectively choose to create tables or other database objects and their components, such as primary and foreign keys, indexes, and constraints. Use the formatting options to include header, object and column comments, and more. Control DDL generation with templates to ensure that database definition language generated directly from the model complies with team, organization, or industry standards. Use the flexible and productive DDL template editor to specify the format and structure of DDL generated from the models. Use the system templates or modify them to suit your organization's database standards. Insert macros such as conversion to camel case to simplify the templates and reuse functions. Configure and customize data types for all the leading relational database systems. Data types are critical to data modelers and are used when specifying column definitions for tables in physical data models. After selecting the database product name, you can view or refine the system-defined data types, including length and precision. You can also define your project, team, platform, or organization-wide data types. Set the default database system for the repository, ensuring that the database system type will be preset when you create new tables in a physical data model. Use the built-in editor for database definition language or specify your preferred editor. You can also set the storage engine for MySQL databases. Define constraint and index names that implement your organization's data modeling standards, defining the naming conventions for database objects and constraints. You can use the DDL name template window to define your organization's constraint names using macros that act as placeholders that the tool will replace during DDL generation. For example, a primary key constraint could be prefixed with pk_ and the primary key table name. Map data types for conversion between different database management systems. As a result of mergers or acquisitions or policy changes, you may need to transition from one database system to another, requiring data types to be mapped between the two systems. The tool provides a set of default mappings for supported DBMS products to help you automate the conversion process. Alternatively, you can customize the default mappings to suit your specific project requirements or where the mapping of one data type to another is not currently defined. Link to other business and technical models. In this topic, you will see how to connect information models to requirements, process, application, and location models, and add data entities to glossaries. By the end of the topic, you will have seen benefits, including connect to business and technical requirements, visualize the data consumed and created by processes, model geo-databases and link to geographic locations, add data entities at any level to glossaries, and more. Link requirements and data elements to verify that you have designed your data models in response to business and technology requirements. Manage requirements and link them to data model features, including tables, columns, keys and indexes, and other objects, such as views, functions, stored procedures, queries, and more. you can display the requirements in the info view style, showing requirements properties and descriptions on the diagram. Link data modeling entities to business or technology process models to show how data is consumed or produced during the execution of an activity. Link tables and other database objects to BPMN data objects and data stores to show where data is manipulated and stored. You can link conceptual, logical, or physical elements bridging these two separate but related disciplines. Show or hide individual columns, keys, and indexes to ensure the diagram is relevant to the business or technology stakeholders. Model location and geographic features using the geography markup language and visualize the features in expressive diagrams using conventional symbols. Add images to represent features such as airports, aircraft, wind turbines, buildings, and more, to make the diagrams more compelling and appealing to business and informatics stakeholders. Connect these geographic models to conventional data sets to integrate these two aspects of solution architectures. Generate industry-standard application schemas directly from the models, or create highly polished corporate documentation in various formats, including PDF and DocX. Model location with ArcGIS databases using the inbuilt support for geodatabases. Many 21st-century systems have a spatial component as location becomes key to human activity in domains like travel, real estate, rescue, utilities, cityscapes, and more. You can create ArcGIS models and diagrams that allow you to visualize the geographic features, domains, and other elements that make up a geodatabase schema. You can import and export models to and from ArcGIS databases. Discover requirements sourced from documents stored inside or outside the repository. Bridge the gap between these text-based sources of project information, and the requirements derived from them. As your project evolves and implementation work begins, you can trace any part of the model back to the source of the requirements, by using tools such as the matrix and traceability window. Define navigation diagrams with buttons that launch data model diagrams, making it easy for any business or technical stakeholder to navigate through the model. Include navigation icons to describe the type of diagram or information that the button will launch. Use the navigation buttons in the browser views, including Prolaborate and WebEA on smartphones, tablets, and notebooks. Target other navigation diagrams such as projects or disciplines to allow drill down through the model. Put meaning at your fingertips with the powerful glossary tools that ensure teams are on the same page and have the same mental model of terms and definitions. Readers will see the meaning of industry, project, or team terms as rollovers in diagram, element or connector notes and other model-based project documentation. Create categories of terms based on disciplines, semantic fields, source, and more. Turn any project element into a glossary term by adding it to a glossary diagram. You can also include the glossary items and their meanings in a corporate publication or web page. Add data objects, including conceptual, logical, or physical data model elements, to a glossary diagram to incorporate them into a model glossary. Text in element notes, discussions and other windows will hyperlink the terms and display their meaning on rollover. The tool categorizes the items by the diagram name, which is displayed as a prefix to the term. Communicate, collaborate, and integrate with Model Exchange. In this topic, you will see how to collaborate with colleagues and customers, create corporate publications, and exchange content with other tools like Excel and SharePoint. By the end of the topic, you will have seen benefits, including view real-time data models in a secure browser, create curated views with Prolaborate dashboards, collaborate with colleagues with chat, discussions, and mail, exchange data with spreadsheets and tools like Jira, and more. Put data governance, architecture, and design in your pocket and instantly view real-time models in a browser no matter where you are. View the data models and related content on a notebook, tablet, or smartphone, and create new requirements, constraints, issues, decisions, and more, adding notes and other details as required. Collaborate with colleagues, consultants, and customers by entering into discussions, chat, reviews, and viewing each other's model additions and changes in real time. Visualize models in Prolaborate, and view data modeling information in tailored dashboards that present models in diagrams or compelling and interactive charts, providing insights into the models. Create curated views for different audiences, such as a security architecture view. Implement governance by allowing individuals or groups to change table or column metadata for specified database objects. Visualize a data dictionary and drill down between conceptual, logical, and physical models. Generate high-quality corporate documents directly from the model. While the world is moving to real-time information portals and Enterprise Architect has web-based views of the models, there are still circumstances such as contractual obligations and compliance with standards where formal documentation is required. Use a range of document generation techniques with flexible system or user-defined templates. Completely customize the documents to comply with corporate or customer standards, including styles and logos. Generate these for publication in various formats such as DocX and PDF. Collaborate with customers, colleagues, and consultants, and build systems in record time using the collaboration and team features. Enterprise Architect is built from the ground up as a collaboration platform for sharing ideas and working and modeling together. Collaborate with your team and stakeholders no matter where they are located, and chat, discuss, comment, review, and share strategies, architectures, solutions, and visualizations, all in real time. Ensure you are on track with reviews of essential or critical parts of your model. Invite colleagues or others, like customers and consultants, to review model content such as architecture descriptions, principles, catalogs, and diagrams. Conduct reviews inside the desktop tool or in a web browser using the powerful collaboration features of the ProCloud server. Integrate your Enterprise Architect models with other platforms, including SharePoint, Jira, ServiceNow, Team Foundation Server, and many more. Set up the integrations with the ProCloud server and then push and pull information to and from the external tools. Collaborate in real time with users of other platforms that support discussions and comments, and share diagrams through a browser using WebEA or Prolaborate. Bring teams together and visualize a wide range of enterprise data from multiple platforms in a single pane of glass. Use the CSV Exchange utility to exchange requirements, conceptual and logical entities, decisions, issues, risks, and other elements with spreadsheets. Save time and effort by importing existing definitions from spreadsheets, including inbuilt properties such as type, status, and priority, or user-defined properties such as the business owner or criticality. Create and reuse your specifications for both import and export of modeling information. Check for high-quality data architectures and designs and see how your models stack up, by applying a checklist to data architectures, models, or individual elements. Extend the checklist to other elements such as conceptual, logical, and physical data models, tables, procedures, functions, and more, to ensure rigor and standardization. Use a checklist pattern of predefined quality characteristics, or define your organization, project, or team qualities for each element type. You can edit the checklist and add or remove items. In this presentation, we have covered the following topics: manage entity relationship, conceptual, logical, and physical data models. Connect to live databases with the Database Builder. Transform models and generate database definition language. Link to other business and technical models. Communicate, collaborate, and integrate with Model Exchange.